So we're working on our review for our Major Quiz 3. I realize I wrote Exam 3, but it'll be Major Quiz 3. And the first thing we're looking at is finding the distance. So there's a formula. You can do it either way. So I don't remember which one is actually the exact formula, but it doesn't really matter because these two parts are being added. So as long as you're subtracting that part and adding the two parts together, there's no difference in what the value you will come up with. And it's just the same thing as, it doesn't matter which point you pick as point 1 or point 2, as long as you go the same way. You know, it's kind of like with the slope. It doesn't really matter which way you go because of what's happening. And the subtraction doesn't matter because you're squaring both parts anyway. So we're going to look at our first one here. Our point is 8, 6, and 4, 9. All formulas will be provided on your exam, so they'll be available to you. And so with that, first thing I want to do is I want to label which is going to be which part. So x1, y1, x2, y2, so I don't grab the wrong ones because I don't want to grab the wrong number. So I've got d equals the square root, and it doesn't matter which way you go. I think on this one I'm just going to go with the y's first because it doesn't matter. So we're going to have 9 minus 6 squared plus 4 minus 8 squared. So this will be equal to the square root. 9 minus 6 will get me 3 squared plus 4 minus 8 is negative 4 squared. Now, if you notice, I always do parentheses because with this, you've got to square the whole thing. So you're going to end up, when you get to this next part, I have 9, because 3 squared is 9. Negative 4 squared will get me positive 16. Both of these numbers should always be positive because you're squaring the whole number. So you shouldn't have any negatives. 9 plus 16 is 25. Square root of 25 will get you 5, and that would be your final answer. So that's the distance between the 2 points. All right, on this one over here, again, we need to label our point. So x1, y1, x2, y2. So my d will be equal to the square root. This time, it doesn't really matter which way we go. It really doesn't if you're using the x's. We'll do the top way this time because I want you to know it doesn't matter because of the addition process. If we were subtracting here, it would be different, but because we're adding, it doesn't matter. So we're going to have 5 minus 3 squared plus 7 minus 4 squared. What changes in this formula is like we did here, we had 9 plus 16. If we had done the x's first and then the y's, we'd have 16 plus 9. So that's where it just doesn't matter. Because I know sometimes you guys worry about that. All right, square root. 5 minus 3 is 2 squared. 7 minus 4 would be 3 squared. So that'll get us 2 squared is 4, plus 3 squared is 9. 4 plus 9 will get us 13, and we're just going to leave it at that. So square root of 13. All right, so that's doing the distance. Now we're going to look at the midpoint. We're going to find the midpoint. We've got 2 points we're going to do here. So our midpoint formula, we're going to add the x's and divide by 2 and add the y's and divide by 2. Think about midpoint. It's the middle point of it, so it's in the middle, so it's about halfway. So that might help you recognize the formula. All right, so all we're going to do is take our, and let's label again, x1, y1, x2, y2. So we take our x's, we have 8 plus 4 divided by 2. Comma, 6 plus 9 divided by 2. Now, in this, let me make sure you understand. You have to put the parentheses because this is a point. If you're not doing the parentheses, if you leave it off, you will not get full credit. Also, if you notice when we did the distance, I put the square root all the way down. We don't just do part of it. So make sure you're doing your notation very well. So 8 plus 4 will get us 12 divided by 2. 6 plus 9 will get us 15 divided by 2. So 12 divided by 2 will get us 6, and we'll leave this one as 15 halves. Okay, let's go do this one. So again, x1, y1, x2, y2. Alrighty, so we have 3 plus 5 divided by 2, and 4 plus 7 divided by 2. 3 plus 5 will get us 8 divided by 2. This will be 11 divided by 2. 8 divided by 2 would be 4, and 11 halves. You won't always have a fraction answer, but sometimes you're going to, and that's okay. All right, let's go to our next problem. So the next one we're looking at, we are writing. So we're going to write with positive exponents. Using radical notation. Now some of these you won't always have to do the radical notation. It just kind of depends on what happens with it. All right, so our first problem, we're looking at x to the 2/3 over x to the 1/3. They already have a common denominator. I'm going to use my exponent rules to start with this. So I know that I have more positive x's up here than I do down here because it's 2/3 versus 1/3. So I'm going to bring this up, and remember when you cross that fraction line, the exponent will change its sign, so we're going to subtract it. So x to the 2/3 minus 1/3. And because I have that same denominator, I can just make it x to the 1/3. Because 2/3 minus 1/3 will get us 1/3. This would be also, if you were writing it with a radical, you could change it into the cubed root of x. But if it says to write with positive exponents, and so x to the 1/3 would be doing a positive exponent. But we could also change this into the cubed root of x. These are equivalent answers. All right, let's look at B. So we have 81 to the 1/4. So what we're going to do with this one, we're going to use more of the radical notation here. So that bottom part, just like it was up here, the third goes there. I want you to understand the exponent part of it. We would have the 4th root of 81. That is a perfect 4th root right there. It's actually going to be the 4th root of 81 is 3. And then, because it's 3 to the 4th, so that would be your final answer there. For part C, we have 27 being raised to the 2/3. So here we will do the cubed root of 27. 27 is a perfect cube, and then afterwards we'll square it. So cubed root of 27 again is 3, and 3 is going to get squared, and it will be 9. Our next one, we are looking at negative 81 to the negative 3/4. When we have a negative exponent out there, we're going to have to take it down into the denominator. So 1 over negative 81. Hang on 1 second. I think we shouldn't have a negative on there, so let me just look real quick. Yes. So this should be positive 81. Sorry about that, because that's going to be an issue because we can't take the 4th root of a negative number. All right, so 81 being raised to the positive 3/4. Now what we can do is change this to the 4th root of 81, and then we will cube it. So So the fourth root of 81 is again 3, just like we saw a little bit ago. So 3, and that 3 is going to be cubed, and 3 cubed will get us 27. So it'll be 1 over 27. All right, last one of this type, we are looking at multiplication. So y to the 1/4 times y to the 1/5. So we're going to need to add those. That's what happens with our exponents when we multiply. So y to the 1/4 plus 1/5. We have to now get a common denominator. So 4 and 5, the common denominator would be 20. So I'm going to have 20 plus something over 20. I multiply 4 times 5 to get to 20, so I have to multiply the top of my fraction also by 5. So that'll be 5 over 20. 5 got multiplied by 4 to get to 20, so 1 times 4 is going to get 4. So adding those together, I get y to the 9/20. And then I can write this as a radical as the 20th root of y to the 9. Alrighty. So that's looking at using positive exponents and radical notation so that you understand what's going on. Okay, so our next question that we're looking at will be number 4. We are going to solve inequalities. So we're looking at part A. We have 5x minus 2 greater than 3x plus 6. So I got to decide which way I want my x's to be on. I'm going to put them on the left side because there's more of those and I like it to stay positive, so I don't have to use that rule of multiplying or dividing by a negative. I can just keep it positive if it's possible. So I'm going to subtract my 3x. This will get me 2x minus 2 greater than 6. Add the 2 over, and we get 2x is greater than 8. Divide by 2. And we have x is greater than 4. So now we're going to draw it on a number line. All you need are the numbers you're using. You need the 4 and you need the infinities. X is greater than 4. Greater than goes to the right. And because we don't have an equal to part, it will be a parenthesis. And our interval notation would be 4 to infinity. All right, let's look at another one. So if we have 7x plus 3 greater than or equal to 4x plus 9. So again, when I'm looking at this, I have more positive x's on the left side than the right, so I'm going to move my x's over. That'll leave me with 3x plus 3 greater than or equal to 9. Subtract the 3. 3x is greater than or equal to 6. Divide by 3, and x is greater than or equal to 2. So x is still greater than, so it'll still be going to the right this time. I have a 2. I need my infinities. So it'll be greater than, we'll go that way. And because we have the equal to, it will be looking like that. Bringing that down to interval notation will be bracket 2, infinity, parenthesis. All right, so when with these greater thans, they go to the right. Now let's go look at a couple more of these. So we're looking at part C. We have 3 times x minus 4 less than or equal to 4 times x minus 2. First thing I need to do is distribute. So 3 times x is 3x. 3 times negative 4 is negative 12. Less than or equal to 4 times x is 4x, and 4 times negative 2 is negative 8. Now I have 3 x's here and 4 x's there, so I'm going to move my x's over. So minus 3x gets me negative 12 less than or equal to x minus 8. Add my 8 to the other side, and I get negative 4 less than or equal to x. So now looking at putting it on the number line, I need my negative 4 and my infinities. So x is greater than, because it's on the wider side, negative 4. So greater than is going to take us to the right. Even though it's facing the other way, it's still on the greater than side. And it's got an equal to, so it's still going that way. All right, so this will get us negative 4 to infinity. Now let's look at one more. So we have negative 15 minus 3x greater than or equal to 6. All right, so we only have x's on one side, so let's add our 15 over. We have negative 3x greater than or equal to 21. Divide by the negative 3, and we have an x here, we have a negative 7 here. Now what we have to do is allow for that, the dividing by the negative, so we have to flip our inequality sign. It goes this way. Otherwise, we won't have the same answer as if we moved the 3x over to keep it positive. So x is now less than or equal to negative 7. And now we'll draw our number line. We need a negative 7, and we need our infinities. X is less than, so it's going to go to the left. And it's got an equal to part, so it gets a bracket. So negative infinity to negative 7 with a bracket. All right. Next one, we're going to use some radical notation. So this will be number 5. We're going to use radical notation to simplify. Write the expression and simplify. All right, so part A, we have 36 to the 1/2. To the 1/2 power is the same thing as the square root of 36, and the square root of 36 is 6. Part B, we have 81 to the 3/4. That's the same thing as the 4th root of 81 being cubed. 4th root of 81 is 3, and 3 cubed is 27. All right, number 6, we'll write as a single radical expression. All right, so part A, we have the square or the 7th root of x times the square root of x. So what we're going to do is use our exponent rules to do this. So if I write them as x to the 1/7, because our index is 7, times x to the 1/2, because it's a square root, so the index is 2, my exponents get added, so x to the 1/7 plus 1/2. Have to get a common denominator. With 7 and 2, it's going to be 14. So x to the something over 14 plus something over 14. Well, 7 times 2 gets me 14, so 2 times 1 will get me 2. 2 times 7 gets me 14, so 7 times 1 will get me 7. So this will become x to the 9/14, which will then become the 14th root of x to the 9. All right, let's look at B. We have the cubed root of y over the 4th root of y. So I'm going to turn these into exponents. So y to the 1/3 over y to the 1/4. I need to get a common denominator between 3 and 4, which would be 12. So y to the 12 over y to the 12. So 3 times 4 gets you 12. Because we multiply by 4, 4 times 1 will get us 4. 4 times 3 gets us 12, so 3 times 1 will get you 3. So we have a 12th denominator, and now we can look at our tops. I have 4 up here and 3 up here, so we're going to move these up using subtraction. So y to the 4/12 minus 3/12 will end up being y to the 1/12, which will be the 12th root of y. Okay, so, and you could go ahead and move it up and then see where they land, but I like doing the denominators first and then figuring it out, so I have less steps. Try to work smarter and not harder and not have to do extra steps if I don't have to. All right, so number 7. On number 7, we are adding and multiplying, or multiplying, so add or multiply the radical. So for part A, we have 2 square roots of 11 plus 5 square roots of 11. Well, they're the same root, and they're the same index. So they're both 11, and they're both squares. So I can just add those. 2 plus 5 will get us 7 square roots of 11. Part B, we have the cubed root of 24 minus 4 cubed root of 81 plus the cubed root of 3. Well, they are all the same index of 3, but my radicands, or my roots, are not the same. So I'm going to have to break these down and simplify them. So 24, you need to factor it down. I'm going to use 4 and 6. We could have done 2 and 12, or 3 and 8. So 4 becomes 2 and 2. 6 becomes 2 times 3. So this becomes the cube root of 2 times 2 times 2 times 3. 81 would be 9 and 9, 3 and 3, and 3 and 3. So minus 4 cubed root of 3 times 3 times 3 times 3. And then this one, there's nothing to do with it. So it is cubed root of 3. So now we're looking for our groups of 3 of a kind. I have 3 2's here that will come out. And that will get me 2 on the outside, cubed root of 3 left. Minus 4, I have 3 3's that will come out. So times 3, cubed root of 3, and then plus our cubed root of 3. So this will be 2 cubed roots of 3. Negative 4 times 3 will be minus 12 cubed roots of 3 plus the cubed root of 3. Now that they're all cubed roots of 3, I can combine this. So I have 2 minus 12 plus 1. And when I add that, I will end up with negative 9 cubed roots of 3. And that would be your final answer right there. So you may have to simplify the radicals so that you have the same index and root going on, the radicand. All right, let's look at number 8. Oops, sorry. We've got a part C going on here. Sorry about that. All right, we didn't do any multiplying. Square root of 5 times 2 plus the square root of 15. So here we're multiplying. They don't have to be the same radicand, but they have to be the same index, and they are squares. So this will get us 2 times the square root of 5 will be 2 square roots of 5. Square root of 5 times square root of 15 is going to get us 5 times 15 is 75. And then we have to see if we can simplify it all. Well, square root of 5, 5 is a prime, so nothing's going to happen there. But 75, that's 3 times 25. Oops. Yeah, we can just do 25 times 3. And 25 will become 5 and 5. And so here we'll have 2 square roots of 5 plus we'll have 3 times 5 under our radical, looking for a group of 2 of the same. So we'll have 2 square roots of 5 plus 5 square roots of 3. And that would be our final answer right there. All right, let's go do D. So we have 7 square roots of x plus 5 times 3 square roots of x minus 4. So when we multiply this, we have 7 times 3 is 21. Square root of x times square root of x will be the square root of x squared. And then we have 7 square roots of x times negative 4, so minus 28 square root of x. 5 times 3 square roots of x will get us plus 15 square roots of x, because 5 times 3 is 15. And then 5 times negative 4 would be minus 20. Now, if you notice, these two here are like terms, so we'll add those together and get 21. Square root of x squared will get us x. Negative 28 plus 15 will get us a negative 13 square roots of x, and then minus 20. Nothing else are like terms, so we won't be able to do anything more than that. All right, now let's go down to number 8. And here we're going to write the conjugate. So we're just writing what the conjugate looks like, and we're doing that so we understand how to do the next problem. So for part A, if I give you the square root of y minus 6, the conjugate, all we do is change that middle sign, so the conjugate would be square root of y plus 6. If we look at part B, and we have negative 3 square roots of 11 minus 4 square roots of 11, our conjugate would be negative 3 square roots of 11 plus 4 square roots of 11. You don't change this sign, you only change the sign in the middle. And remember, we write the conjugate. We need to know how to do that because if we're trying to rationalize our denominators, we have to sometimes use the conjugate to get rid of all of the radicals in the denominator, because this basically becomes the difference of squares when we do the multiplication process. All right, let's go look at number 9. So for number 9, we are going to rationalize the denominator. So with rationalizing the denominator, part A, we have the square root of 11 over the square root of 7. So rationalizing the denominator means we don't want radicals in our denominators. So we're going to do what we need to get this, in this case, a perfect square. If it was a cubed root, we do a perfect cube. So what I want to do then is multiply by 1, and that 1 will look like whatever I need. In this case, I need a square root of 7, so that I have square root of 7 times square root of 7 makes it a, the inside will be a squared number, so I can take the square root. And what I do to the bottom of our fraction, I do to the top. Or what I do to the denominator, I do to the numerator, whichever way you want to look at it. So on the top, we have the square root of 11 times 7 is 77. And on the denominator, you can either make this 49 or you can look at this as 7 squared. You can look at it that way because in other cases we'll have a square term, or you can write it as 49. It doesn't matter either way. So now I can take the square root of something that is a perfect square, in this case 7 squared or 49. So I have the square root of 77 divided by 7. So now we don't have a radical in the denominator anymore. All right, let's look at part B. So if we have the square root of 64 over y, first thing I have to do is break this up. So square root of 64 over the square root of y. So I separated the fraction and put radicals on both. Now the square root of 64 is actually a perfect square over that square root of y. And now I need to rationalize my square root of y. So I need another square term, so it's going to be multiplied by the square root of y. So this now gets us 8 square roots of y over the square root of y squared. Square root of y squared will get us y in the denominator, and now we're done with that one as well. All right, let's look at C. On C, we have 6 over 2 minus the square root of 7. So because we have a subtraction going on here, we're going to have to multiply by the conjugate. It's not just a single term. In the previous two, we had a single term, but this one we don't. We have two terms. So 2 plus that square root of 7. That is our conjugate. All right, this will become 6 times 2 plus the square root of 7 on the top. And on the bottom, we have 2 minus the square root of 7 times 2 plus the square root of 7, which is a, we can see that this will turn into a difference of squares. All right, so on the top, we have 6 times 2 plus square root of 7. I don't usually multiply that out till I see what I get in the denominator, because sometimes the denominator and the numerator will reduce, and so I don't do it until the very end on the top. All right, so we have 2 times 2 will get us 4. 2 times square root of 7 plus 2 square roots of 7. Negative square root of 7 times 2 would be negative 2 square roots of 7. A negative square root of 7 times a positive square root of 7 will be minus square root of 7 squared, which is the same thing as square root of 49. All right, so we have our 6 times 2 plus square root of 7 over, we have 4. These two here will cancel because they are the same thing but opposite signs, and that should happen every time when we're doing our conjugates. And then square root of 49 is 7, so minus 7. So this will get us 6 times 2 plus square root of 7. And 4 minus 7 will get us a negative 3. So then 6 will divide by negative 3. It'll go in there 2 times. So negative 3 goes into 6. It'll become negative 2. So now we have negative 2 times 2 plus that square root of 7. And now we can multiply that out and get negative 4 minus 2 square roots of 7. And that would be our final answer. All right, so that gets us, and this is the reason I wait to do this. Because if you go ahead and multiply that out, now you're going to have to factor out a common factor of 3. So I wait till the very last to do that. Alrighty, let's look at one more of these. So if we have 3 over the square root of 7 minus 4, then on this one, our conjugate will be the square root of 7 plus 4 over the square root of 7 plus 4. So on the top, we have 3 times square root of 7 plus 4, and on the bottom, we have the square root of 7 minus 4 times the square root of 7 plus 4. Now, you don't have to write this step part here. You can go ahead and do the multiplication, but I do it so that you can understand what all I'm multiplying here. So on the top, we have 3 square roots of 7 plus 4 happening up there. And on the bottom, we have the square root of 7 times the square root of 7, which is the square root of 49, because 7 times 7 is 49. And then we have square root of 7 times positive 4, so plus 4 square roots of 7, and then minus 4 square roots of 7, and negative 4 times positive 4 would be negative 16. All right, so now we have 3 square roots of 7 plus 4 in parentheses over square root of 49 is 7. These two will cancel each other out, so 7 minus 16. So this will get us 3 times square root of 7 plus 4 over 7 minus 16 will be negative 9. 3 will go into negative 9 3 times, keeping that negative. So now we'll have the square root of 7 plus 4 over negative 3, and that would be our final answer. Alrighty, so we have one more problem to look at. This is number 10, and we are going to solve. We're solving some radicals. So for part A, we have the square root of x plus 1 equal to 5. So here, in order to solve for x, we have to get it out of the radical. So what we're going to do is we're going to raise it to the same index. So x plus 1, we're going to square both sides. So this square will take care of that square root. So we have x plus 1 equal to 5 squared, which is 25. Subtract 1 from both sides, you get x equal to 24. Now, because we squared, we always have to do a check on these. So to check it, we're going to plug it into the original. So we'll have 24 plus 1 equal to 5. 24 plus 1 is 25. And square root of 25 is 5, so it checks. All right, let's see if we can get B right over here. We have the square root of 2x minus 3 equal to 3. So again, we're going to square both sides because the squaring will take care of the square root. So we get 2x minus 3 is equal to 3 squared, which is 9. We'll add the 3 over and get 2x equal to 12. Divide by 2, and x will be equal to 6. And then we'll check it, because you can get erroneous solutions with these because you're squaring them. So as we check it, we get square root of 2 times 6 minus 3. We want to know if it equals to 3. 2 times 6 is 12 minus 3. 12 minus 3 is 9. And the square root of 9 is 3. 3 equals 3, so it works in both cases. It will not always work, as we saw when we were learning this, and also in your homework. Make sure you study and do your best on the exam.